This is the tennis team's final presentation where we're taking a deeper look into the gameplay of tennis and how psychological nuances affect a player's performance and a match's outcome. Our primary motivation is that we want to understand more about the psychological nuances behind tennis, which can be essential in predicting the outcome of a match and understanding a player's form and performance. This can also be beneficial for players to improve their mentalities and their overall gameplay. Some of the questions that we ask are tennis matches streaky, where streakiness refers to the tendency of a player to win more points in a row or lose more points in a row, and we want to understand if this is actually a true phenomenon or not, and if it is, then it can be beneficial for predicting the outcome of a next match based on previous points. Another question is, do some tennis players choke more often than others in high pressure situations, where choking refers to a player performing worse than they would be expected to in a certain situation, where those are usually in the context of high pressure situations. Some people in the tennis community may also label tennis players as natural chokers, and we want to see if this is truly the case. If a player is more likely to choke in a situation than others, then it could be an avenue to explore to improve their overall gameplay. And finally, how does tennis gameplay change over the course of a match? We want to understand this so that we can see if there are any strategies that players could come up with that could abuse this and get an advantage over their opponents. These are the three datasets that we'll be using in ascending order of granularity, with the ATP tennis stats dataset and match charting dataset generally reflecting the same time period from 1968 to 2022, but we'll be focusing on 2011 to 2021, and the ATP tennis stats dataset will have some overall match information, and the match charting will have some more in-depth information of some of those matches. And lastly, there is a Grand Slam point-by-point dataset, which gives point-by-point information for men's single matches in Grand Slam tournaments from 2011 to 2021. In the table above, you'll find some feature information for the datasets that we used. For our data wrangling, we had to first choose a time period that we'd use, and so we chose 2011 to 2021 so that we could use the point-by-point data as well as the overall match data. Another thing that we had to change was that some player names and match IDs weren't standardized across different tournaments, or some names also may have contained special characters and things. So we chose to standardize player names by first initial followed by last name. And then we also had to drop some features that were missing a lot of values.
To analyze streakiness, we first hypothesize that streakiness exists in tennis, and we'll use the mark charting dataset to prove it. For each server, we'll keep track whether they've won the most recent point they serve or receive, and then calculate the win percentage when they serve and receive. We'll use the Laplacian smoothing and some ghost point to make the win percentage less noisy. For model choice, we'll use linear and logistic regression, and each type of model will be trained on two cases, knowing the win percentage and the sequence of the last 5 points, or only knowing the win percentage. For choking, we'll hypothesize that some player, notably Grand Slam winner, will tend to choke less than other players, and we'll use the Grand Slam point-by-point data plus the ATP matches to prove it. We'll have two approaches. First, we'll calculate a choking percentage based on one scenario of high-pressure situations, which is facing breakpoints. For each breakpoint, we'll calculate the win percentage of normal and breakpoints by the server and receiver, and then calculate the choking percentage and highlight some of the Grand Slam's winner choking percentage. For the second approach, we will define 5 different high-pressure situations and 2 new independent variables. First one is pressure points, which is the level of pressure each point is, and a post error, which is an indicator variable telling us that if a preceding point was an unforced error or not. And we'll use generalized mixed effect models to predict the choking percentage, and the model will be evaluated using odds ratio, confidence interval, and p-value. And finally, for gameplay changes, we hypothesize that as the match goes on, the likelihood of player hitting an arrow will increase and the likelihood of winner will decrease. We will use the mark charting dataset combined with the Grand Slam point-by-point to prove it. For each set in the match, we'll calculate the percentage of unforced error and winners of each set by the players. And then we'll use two generalized linear mixed effect models to model the effects of set number or the probability of unforced error and winners. They will also be evaluated using OR, CI, and p-values.
Next, we're going to go through the results for each of our research questions. Firstly, for streakiness, we found only a very, very, very small difference between our model that knows the outcomes of recent points and the model that doesn't. The values you see in the table are the mean squared error for our predictions. Lower is better. So M1, which knows the outcomes of recent points as well as win percentages throughout the match, is only a couple 10,000ths better than the model that just knows the win percentages. And this is not even much better than guessing the same value every time. We're still working on validating whether this difference between the models is significant, but even if it is a minuscule effect. As for choking, we had two different approaches. Our first approach compares players' performance on breakpoints versus all other points, considering a player to choke if they perform worse on breakpoints than on regular points. We were surprised to see that several top players have unusually high choking percentages, which was surprising. In our second approach, we found that players tend to hit unforced errors more often in higher pressure situations, and even more so if they'd hit an error on the previous point. And we found in this case that certain top players like Federer and Djokovic had the opposite trend, performing better in high pressure situations. And finally, when we examined gameplay changes, we found that players hit winners more often and unforced errors less often over the course of a tennis match, with an especially dramatic trend after set 1. This was a little surprising to us because we expected players to get tired and play more softly as the match goes on, but we observed the opposite. We of course have to evaluate whether these results are valid. For streakiness, we're still working on our validation, but the plan is to compute what's known as the AIC for each model and compare them to see if there's a significant difference. Then for our first approach to choking, we computed what the variance is expecting to be if choking is not a real effect, all randomness, and we compared that to the observed variance, and we found that the variance in each case is approximately the same, suggesting that the choking stat we used in the analysis is mostly random chance. For the second approach, we computed p-values for our two predictors and found that both of the p-values are very, very low, suggesting those predictors are both statistically significant. And we found the same thing for gameplay changes, suggesting that the changes from set to set are also real and not just random chance.
So to summarize, we found that higher levels of pressure increase the chance of an error, and being able to maintain error rate low enough and winner rates high enough is essential in winning a match. Winning or losing multiple points in a row does not have a significant advantage and disadvantage in the next point, but being able to win key moments is more vital. A successful player perform better and more stable than general champs because they have a greater mentality during high pressure and longer matches. Therefore, enable players to be more successful, identifying these key moments can have a great effect on their mentality and performances.
When considering construct validity and streakiness, our approach uses granular point data, so it works for short timescales but not for long ones. In our first approach for choking, we use breakpoints for high pressure. They are a good but not perfect approximation. For the second approach, we have more factors, but we may still miss some. We use unforced errors because we think that it is more related to pressure, but it's hard to tell whether it is actually influenced by pressure. For gameplay changes, unless there are scorekeeping errors, we should have good construct validity. When considering internal validity for streakiness, it's possible that some factors can create streaks without streakiness, such as a player injury. In our first approach for choking, we found no evidence that opponent quality affects a player's choking percentage. In the second approach for choking, our data may be confounded by weaker players more consistently finding themselves in high-pressure situations. For our analysis of gameplay changes over time, it's theoretically possible that matches have different number of sets, but this trend holds between sets 1 and 2. When looking at external validity, our trends are applicable to men's single Grand Slam tournaments from 2011 to 2021. Unless there is a drastic change in tennis play, it can be extended to a few years outside this range, but not much more than that. Our trends may also be applicable to high-level male players looking to join the Grand Slam men's single matches, but not the general audience, because pro tennis players and high-level players may have more stamina, making them less tired in long matches. In our first approach for choking, we excluded some players which did not play enough matches, but this population may have a different choking percentage than the players that we did analyze. Limitations of our dataset include that we do not have pre-2011 data for Grand Slam points, so there may be some biases here. Match charting is given at a voluntary basis, so there are definitely biases here, and data collecting in Grand Slam tournaments changed in 2018, so there are some inconsistencies. In analysis, we cannot accommodate for internal and external factors such as climate and injuries that may affect a player's mentality. We would like some feedback on streakiness, choking, gameplay, and our overall project.